I want to do a bonus lecture on translations and predicate logic just for fun. So here are some, I think, some interesting examples of how predicate logic can capture some really interesting relationships that propositional logic can't. These first slides, I'm going to use the example of a deck of cards. So with a deck of cards, some of them are red and some of them are black. So here are the ones that are red, here are the ones that are black. As you can see, that takes into account all the cards here. So I could say all cards are red or black. And we know that's true. So how would I symbolize that? Well, since I have an all statement here, hopefully you can see that this is going to be a universal quantifier. And then what are my predicates? Well, my predicates are going to be red and black. So we can use R and B to represent those. So we get something like this, where we have a universal quantifier saying all things are red or black. How about this statement? Some cards are face cards. So all of these over here, every jack, queen, and king, are face cards. Now, are all cards face cards? No, obviously not, because look at all these other cards to the left of those that are not face cards. So how would we symbolize this? Hopefully you can see that we have a sum statement here. So that would be an existential quantifier. Then we have a predicate, which is face cards. And so we would symbolize it with something as simple as this. There exists something and it's a face card, or some cards are face cards. Okay, how about this statement? Some cards are even if and only if they are odd. So all of these cards are even cards, which means that they aren't odd. They can only be one or the other. So it's an if and only if statement. Again, we have a sum at the beginning here, so limiting how many of these cards there are that have this condition. And so how would we represent this? Well, sum is going to be an existential quantifier. If and only if, that's a double arrow. Even is one of our predicates. Odd should be the other predicate. And then we see that we got a negation in front of that predicate. So it looks something like this. Some cards are such that if, they are even if and only if they are not odd. What about this statement? So all cards are such that if the card is a heart, then that card is red. So all of these are hearts. And yep, look, they're all red. So this can be a universal statement. And you can see that we have an if then. And then we have a predicate for heart, and we have a predicate for red. So it turns out that we could write this sentence as all cards are such that if it's a heart, then it's red. Now we could flip this conditional around, but it's going to change the quantifier that we use in the sentence. So imagine that we say some cards are such that if the card is red, then that card is a diamond. Because look, these cards are diamonds, but hearts are also red. But doesn't change the fact that some cards, that if they're red, then they're a diamond. So we could write this sentence or translate this sentence such that there exist cards that if they're red, then they are diamonds. But we could also change the conditional statement around a little bit. So we could say all cards are such that if the card is red, then that card is a diamond or a heart. So all of these are the red cards. And you could see that they're either a heart or a diamond. So we can write this sentence. All is going to be a universal quantifier. We have an if-then statement. That's an arrow. R will be our predicate letter for red. And then we have diamond and heart. Those are both one-place predicates too. So we could write something like this. All cards are such that if that card is red, then it is either a diamond or a heart. If we want to be more exact, if you buy a deck of cards, there are typically a couple jokers in that pack. So really, some cards are neither even nor odd, namely the jokers. So how would we symbolize this? Well, first we have to identify our quantifier. So we have sum. It's not an all statement, so it's a sum statement. So that's going to be an existential quantifier. And then we have even and odd. Those are going to be predicates that are going to be associated with our quantifier. Then we have neither nor, and this is where it gets tricky. If you remember when we did our translations before, I told you that you can represent a neither nor statement in one of two ways, so I've got them both here. If you want to make it a conjunction, then both the conjuncts have to have negations. If you want to have a wedge statement or a disjunction, then the tilde has to appear on the outside of the parentheses like this. But if we read this, it says, there exist some cards that they are not even and they are not odd, or there exist some cards that it's not the case that they are even or odd. So two different ways to represent it, but hopefully it makes sense how you're reading it across this way. Maybe this one's a little bit more fun, so pop culture here. So in Survivor, if a player has immunity, then no one can vote for that person. So this is a rule that applies to everyone. So we're actually going to use a universal quantifier to do this translation, because such that if anybody, if all, or it applies to all players that if they have immunity, then no one can vote for them. So how are we going to actually symbolize this? Well, let's think about it real quick before I show you. So immunity, that can be a one-place predicate that that is sort of attached to any player, and then no one can vote for that person. Well, what is voting? Well, voting is a type of relationship where one person is voting for another, so that's going to be a two-place predicate. And no one means that it's a universal statement that applies to everybody. So it would end up looking something like this. It's the case that for all players, if that player has immunity, then it's the case that nobody can vote for that player. Let me do that again. So for all players, that's what this outermost universal quantifier is saying. If that player has immunity, that's what this IX is saying, then all players cannot vote. So all players, again, this rule applies to everybody. Those players who don't have immunity, Y, cannot vote for the person who does have immunity, X. So this X is the same person who has immunity. So if that person has immunity, everybody cannot vote for that person. Cannot vote. I want to end with a couple of examples that are near and dear to my heart from Yu-Gi-Oh! I grew up with Yu-Gi-Oh! Cards, and so I always remember them fondly, and I thought about these two examples of situations in which we can think about the rules in the cards and we can symbolize them in our predicate logic language. So looking at our card over here on the left-hand side, Marauding Captain, we're just going to look at his first effect. So your opponent cannot target face-up warrior-type monsters for attacks except this one. So if we look at my board, as we would say it, so this is the play mat. So imagine that I have Marauding Captain out here on the field, and I have Celtic Guardian, who is also a warrior-type creature. Well, to symbolize this sort of effect of Marauding Captain, we could write something like this. Marauding Captain, if it's on the field, so field being on the field, that's a predicate. So if Marauding Captain's on the field, then all creatures are such that my opponent, the O, cannot attack them if and only if that creature is also a warrior. So here. Say that again. If marauding captain, so M is the constant that refers to marauding captain, is on the field, then the rule is that my opponent cannot attack any monster if and only if that monster is a warrior. And so if we were to try to prove this, I have marauding captain on the field, so F and M are true, or sorry, FM is true, and Celtic Guardian, so C is the constant that refers to Celtic Guardian here. He's a warrior, and so we could conclude that my opponent cannot attack Celtic Guardian. And we could do this proof if we wanted to, but that's how we could symbolize the effect of marauding captain. Granted, I did not play with very many warrior cards growing up. I played mainly with the dinosaur cards and also just like the water cards. So I thought I'd end with two of my favorite cards that I grew up with. So we have Gillosaurus here on the left-hand side, and we're going to have to do quite a bit of work to interpret what the effect of Gillosaurus is and how we symbolize it. So let's just read it first. So you can special summon this card from your hand. When you do, your opponent can target one monster in their graveyard. Your opponent special summons that target to their side of the field. So here on the screen you can see that we have the monster card zones of my opponent and then the monster card zones of myself. And so if I have Gillosaurus in my hand, then I can either normal summon it or I can special summon it. But if I special summon it, then my opponent can special summon some monster from their graveyard. So the way in which I thought to symbolize this was like this. So normal summoning and special summoning, those can be two-place predicates here. So me being the player can normal summon Gillosaurus, that's the G, or me, the normal player, can special summon Gillosaurus. But, remember that ampersand can be and or but, if I special summon Gillosaurus, so if me being the player special summons Gillosaurus, then my opponent here, O, can special summon any monster, that's why universal quantifier, it's unrestricted, as long as that monster's in the graveyard, if and only if that monster's in the graveyard here. So, just going over that again. I can, as the player, normal summon Gillosaurus, or I can special summon Gillosaurus. Me being the player, special summon Gillosaurus. But if I special summon Gillosaurus, then my opponent can special summon any monster if and only if that monster is in the graveyard. So here's an example. Imagine I special summon Gillosaurus here, and then my opponent has Catapult Turtle in their graveyard. Catapult Turtle is actually my favorite card, so just FYI if anybody really cares about that little tidbit of information. So imagine I special summon Gillosaurus here. Then that means that my opponent, so here I've just got symbolized. So I special summon Gillosaurus and Catapult Turtle, so C is the constant to refer to Catapult Turtle. Catapult Turtle is in the graveyard, and so my opponent can special summon Catapult Turtle. And so we could get this conclusion here that my opponent special summons Catapult Turtle. So just again, to go over it, how we're symbolizing this, because we're taking some liberties in how we're interpreting this, but I think it captures the effect quite well. So in Yu-Gi-Oh! You can either normal summon or special summon something. It's saying that I could, if I normal summon it, then nothing else happens. A second condition doesn't work, or doesn't come into play, I guess I should say. But if I do choose to special summon Gillosaurus, then my opponent can special summon anything as long as that thing is in their graveyard. And so I'm going to special summon Gillosaurus, so me being the player special summons Gillosaurus, and my opponent has Catapult Turtle in their graveyard, So they can special summon Catapult Turtle. Opponent special summons Catapult Turtle. So I hope that you enjoyed those examples. I figured that they would be something a little bit different to get some more translation practice. If you have any questions, please feel free to contact me.